Electrolysis is the process of decomposing electrolytes into their component ion by passage of electricity through them. Faraday's law of electrolysis. First law. The mass m of an element deposited in a given voltmeter is proportional to the current I and the time t, or the quantity of charge Q flowing. Thus, M is proportional to Q, M is proportional to IT, M is equal to ZIT, where Z is a constant of proportionality known as electrochemical equivalent, which is the mass of the substance deposited by 1 coulomb of electricity. Z is equal to mass over IT. Faraday's second law of electrolysis. Second law, for a given current and time, the mass of element deposited in electrolysis is proportional to its chemical equivalent or to its relative atomic mass over variance. Thus, mass of copper deposited over mass of silver deposited equals to chemical equivalent of copper over chemical equivalent of silver. Example 1. In an electrolysis experiment, cathode of mass 5 gram is found to weigh 5.01 gram after current of 5 amp flow for 50 seconds. What is the electrochemical equivalent of the deposit substance? Solution. Mass of substance deposited equals to 5.01 minus 5, which is equals to 0.01 gram. Current supplied equals to 5 amp. Time for which current flowed equals to 50 seconds. From M equal to ZIT, where Z is electrochemical equivalent. Substituting for the above equation, we have that Z is equal to 0.1 all over 5 times 50, which is equal to 0.0004 gram per coulomb. Example 2. In copper plating, a current of 0.5 amp is allowed for a cathode area of 100 cm cube. If this current is maintained constant for 10 minutes, calculate the thickness of the copper deposited. The electrochemical equivalent of copper is equal to 0.0033 gram per coulomb. Density of copper is equal to 10 raised to power 4 gram per cm cube. Solution. Mass M of copper deposited is equal to ZIT. M is equal to ZIT. Mass is equal to 0.0033 times 0.5 times 10 100 times 60 equals to 0.99 gram. Volume is equal to mass over density, which is equal to 0.99 gram over 10 raised to power 4, which is equal to 9.9 times 10 raised to power minus 5 per cm cube. But thickness is equal to volume over area, which is equal to 9.9 times 10 raised to power minus 5 all over 10 raised to power 2, which is equal to 9.9 times 10 raised to power minus 7 cm, or 10 raised to power minus 6 cm approximately. Example 3. The electrochemical equivalent of silver is 0.0012 gram per coulomb. If 36.0 gram of silver is to be deposited by electrolysis on a surface by passing a steady current for 5.0 minutes, calculate the current. Solution. Electrochemical equivalent of silver is equal to 0.0012 gram per coulomb. Mass of silver to be deposited is equal to 36.0 gram. Time taken for the passage of current is equal to 5 minutes. From M equals to ZIT, therefore I is equal to M over ZT, which is equal to 36 over 0.0012 times 5 times 60, which is equal to 100 amp. Example 4. Calculate the mass of oxygen liberated at the anode. During electrolysis, if 4 grams of copper is deposited at the cathode, chemical equivalent oxygen is equals to 8, copper is equals to 31.5. Solution: mass of oxygen over mass of copper equals to chemical equivalent of oxygen over chemical equivalent of copper. Mass of oxygen over 4 is equals to 8 over 31.5. Mass of oxygen is equals to 8 times 4 all over 31.5, which is equals to 1.02 gram approximately. Magnetic field. Earth magnetic field. The Earth acts like a magnet. The north geographical pole has south magnetic polarity. Since it attracts the north magnetic polarity, the south geographic pole has north magnetic polarity. Angle of declination or variation. Map are marked with true north, while a compass used to find direction will give magnetic north. The correct angle of inclination marked on the map has to be added or subtracted. Definition: angle of inclination is the angle between magnetic north and geographic north direction at the place concerned. This is the diagram: geographic north, geographic meridian, magnetic south pole, magnetic meridian, magnetic south pole, angle of deceleration. Thus, since the angle of declination involves geographic north, it will be given by d degree plus theta c equal to theta, where d degree is the angle of declination, theta c is equal to compass reading, theta t is equal to true geographic bearing. Example 1. If the angle of declination in a place is 10 east, calculate the true geographic bearing of the compass reading north 40 degrees east. Solution: angle of declination d theta is equal to 10 degree east. Compass reading theta c is equal to north 40 degrees east. Front d degree plus theta c is equal to theta t. Therefore, 10 plus 40 is equal to theta t. Theta t is equal to 50. Therefore, the true geographic bearing theta t is equal to north 50 east. Angle of dip. Angle of dip inclination is the angle between the direction of the Earth's magnetic flux and the horizontal, or the angle which a freely suspended magnet at rest makes with the horizontal. Figure 4.32 resolving the Earth magnetic field. The horizontal component OH, OV is the vertical component, OP is the total flux, and the angle is between the total flux and the horizontal component is the angle of dip. In figure 4.32 above, OP represents the total flux, and so the angle of dip theta can be expressed as tan theta equals to vertical component over horizontal component, which equals to OV over OH, where OH is the horizontal component of the Earth's field at that point. Example 2. A magnetic needle is suspended first at Earth's north magnetic pole and then at the point of the equator. Calculate the respective angle of the needle and the horizontal. Solution: at the Earth's north magnetic pole, the angle of dip is equal to 90 degrees. In the magnetic equator,